What's up, guys? It's Mr. Bringle, and today we're going to be going through acceleration practice problems. So we're going to start off here. You should have already gone through the notes. You should have learned the equation for acceleration. Acceleration is equal to an object's final velocity minus the initial velocity divided by the time interval over which that velocity change occurred. So we've got a quick question here at the top of the page, and it says, what is the difference between positive and negative acceleration? So in this class, we are only going to be looking at objects that are moving in one direction and that we'll define as the positive direction. Things get a little bit more complicated if we start talking about an object moving in a negative direction versus a positive direction. So we don't need to get into that. For the purposes of this class, we will say that if the speed increases, the acceleration is positive, and if the speed decreases, the acceleration is negative. And that is assuming that the object is indeed moving in the positive direction. Okay, so let's go through some practice problems here. We're going to start with our first one that says a paper boy rode his bike at 3 meters per second. After being chased by a dog for 8 seconds, he was traveling 6 meters per second. What is his acceleration? Okay, so the first thing I want to do here is I want to go through and I want to identify things. I want to underline the things that it's given us, right? Because there's a few more variables in this from what we've done in the past. So it says that he's riding his bike at 3 meters per second. But then it also says that later on, after he was being chased by the dog, he was traveling 6 meters per second. So we have to be able to identify which one's the initial velocity and which one is the final velocity. Okay, so if it words it such or like he is riding his bike at 3 meters per second, and then after 8 seconds, it gives you a new velocity. The first one is going to be our initial velocity, and the next one is our final velocity here. Okay, it's obviously given us the time here, 8 seconds. So that is actually going to be the change in time, which is the final minus initial. So we're assuming that he started it at 0 seconds and finishes at 8 seconds. And then it's asking what is the acceleration. So I'm going to circle that one because that's what we're solving for here. As always, we're using the guess method. So we're going to start out with our givens, and we know that the initial velocity of the bike is 3 meters per second. We also know that the final velocity is 6 meters per second. We know that the time is 8 seconds. And then we know that we are solving for the acceleration. Okay, so these are the things that the problem has given us. Our next step is to go ahead and write out the units for the unknown. I always want you to rewrite the unknown here. So we're solving for acceleration. And then we know that we're going to have units of meters per second squared for acceleration. Now, that's just squaring the seconds. So that's an M. Another way to write this would be, if I can get my, or M over the S is the only thing that's squared there. Okay, the S is the only thing that's squared. Okay, and then we'll go ahead and write our equation down. Okay, so acceleration is equal to the object's final velocity minus the object's initial velocity divided by the time interval delta t, or that would just be the object's final time minus the object's initial time. The initial time is always going to be 0 in the problems that we do. So another way to write this would be delta t, which is just the change in time. Okay, so you're just going to put 8 seconds in at the bottom there. Okay, so when we do our substitute step, we're going to go ahead and plug things in here. Okay, so we've got the acceleration is equal to our final velocity, which was 6 meters per second, minus the initial velocity, which was 3 meters per second, over the entire time interval, which is 8 seconds. So we can see here that this is going to end up being 3 meters per second divided by 8 seconds. Okay, so when we solve it here, the acceleration is going to be equal to 3 divided by 8, which is 0.375. And then our units here are going to be meters per second squared. So this is our final answer right here. So what this is saying is that every second, the paper boy and his bike are speeding up by 0.375 meters per second. Okay, so an increase of speed of 0.375 meters per second each second. So after 8 seconds, he will have increased his speed by 3 meters per second from 3 to 6. Okay, let's go ahead and do another problem here. I'm going to scroll down. This time it says a pumpkin is dropped. After 5 seconds, its velocity is 47 meters per second. What is the acceleration? Okay, so a couple keys here. Obviously, it says 5 seconds, so that's going to be our change in time, our time interval. But it only gives us one velocity, and then it says, what is the acceleration? So we know we're solving for that. So this one is, you have to infer something here. So it says the pumpkin is dropped, okay? And then after 5 seconds, its velocity is 47 meters per second. So that is implying that the 47 meters per second is the pumpkin's final velocity in this problem. Now, I want you to think about this. If I take I take something, right, and I drop it, what is the initial velocity of this object? Well, it's 0, right? It's not moving, and then it drops, right? So when we see that it says a pumpkin is dropped, we know that that's going to infer that our initial velocity is 0, okay? So when we write out our givens, we need to actually write that down. We're going to write the initial velocity of the object is equal to 0 meters per second because it's stationary before it moves. The final velocity is equal to 47 meters per second. The time interval, delta t, which is just the final time minus the initial time. The initial time is always going to be 0, so 5 seconds minus 0 would be 5 seconds. And then we're solving for the acceleration. Okay. Now, for our units for the unknown, again, I want you to rewrite the unknown. Acceleration is equal to question mark, and this is going to be in units of meters per second squared. Okay, and again, I'll write this. You can write this as m over s squared like this. It's the same thing, no different than the backslash version of it. All right, and then our equation, using the same equation again, acceleration is equal to the object's final velocity minus the object's initial velocity over the final time minus the initial time, which again you can write as delta t, okay, the change in time. Now for our substitute step, we're going to go ahead and plug our numbers in here. So the object's final velocity was 47 meters per second minus 0 meters per second because our initial velocity was 0. And then our time interval here is just 5 seconds. Okay, so we can see that it's going to end up being 47 divided by 5, which I will go ahead and write out here. So 47 meters per second divided by 5 seconds. Okay, now in our solve step, we are going to go ahead and plug this into our calculator here, and we will find that this is equal to 9.4 meters per second squared. Okay, so again, what this is saying is that when the pumpkin is dropped, it's going to be speeding up by 9.4 meters per second each second. That's what the meters per second squared means. Okay, so after 1 second, it should be moving 9.4 meters per second. And then after 2 seconds, it should have increased to 18.8 meters per second in terms of its velocity, and so on and so forth. Okay. All right, let's go ahead and move on to our third example here. So it says a soccer player is running at 6 meters per second. So that is implying his current velocity. So that's going to be the initial VI. He then stumbles over an opponent's foot, falling and rolling to a stop. Okay, so that is implying his final velocity is 0 because he stopped. Okay, and then it says this took 4 seconds, so that's going to be our time interval or change in time. And then again, what is his acceleration? Okay, so since we are assuming that the object or the player in this problem is moving in the positive direction, and we know that because the velocity is positive, then that means that since he's slowing down, we should get a negative answer. So that can kind of help you check your work at the end. If you can think ahead and think, okay, this object's speeding up, then the answer is going to be positive. If the object is slowing down, the answer should be negative. So we'll go ahead and write out our givens again. Okay, so we know that the initial velocity of the player is 6 meters per second. We also know that he rolls to a stop, and therefore his final velocity is 0 meters per second. The change in time here is 4 seconds, and we are solving for the acceleration. For the units for our unknown, again, please rewrite the unknown, acceleration, and then we know that we're going to measure that. I'm sorry, stylus is being a little crazy here. In meters per second squared. Okay. Our equation, same as always, for acceleration, the acceleration of an object is equal to the object's final velocity minus the object's initial velocity over the change in time, which is final time minus initial time. Now for our substitute step, we're going to go ahead and plug these things in. So the final velocity in this case is 0 meters per second minus the initial, which is 6 meters per second. So you can see here we're going to end up with a negative number in the numerator. And then in the denominator, we have 4 seconds. So this is going to end up coming out as negative 6 meters per second over 4 seconds. Okay. And then we can solve here, and we will show that the acceleration is negative 1.5 meters per second squared. Okay. So as always, make sure that you're actually plugging this into your calculator and you're getting the same answer. Don't just copy it down. That's not going to do you much good. You need to practice using your calculator. So we'll go ahead at this point and move on to our final example here. It says a skateboarder fell doing a jump, and it says that she got up and after 5 seconds returned to a velocity of 5 meters per second. What is her acceleration? Okay, so it's implying, so the skateboarder is initially moving, yes, but then she falls. Okay, so the velocity at that point is 0. And then it says after 5 seconds returned to a velocity of 5 meters per second. Okay, so we are implying that the initial velocity, okay, is 0, and then returned to a velocity of 5 meters per second. That is going to be the final velocity of the girl. Okay, and it says that this took 5 seconds, so that's going to be our time interval. And then again, we are solving for the acceleration. I think it's good practice to always underline and your givens, and then circle the unknown, the thing that you're solving for here. Okay, so the givens, we know that the initial velocity is 0 meters per second. We know that the final velocity is 5 meters per second. The time interval is 5 seconds, and we are solving for our acceleration. That is a crazy question mark. So again, we're going to rewrite our unknown and then write out the units for the unknown, which are meters per second squared. The equation that we will use is the same as always. Acceleration is the object's final velocity minus the object's initial velocity divided by the change in time, or the time interval. Okay. The substitute step. Acceleration is equal to the final velocity, which is 5 meters per second, minus the initial, which is 0 meters per second, divided by 5 seconds. So you can see here that we're going to end up with 5 meters per second divided by 5 seconds. And when we solve, that comes out to be a positive 1 meter per second squared, meaning that at each second, the skateboarder will speed up by 1 meter per second. And that should make sense, right? So if it takes 5 seconds to get to 5 meters per second, then that means that on average, the person has to increase their speed by, or velocity by, 1 meter per second each second. Okay. Make sure that you use the guess method and write all of this down in your notebook. Let me know if you have any questions.